Hello and welcome back, everybody. My name is Noah Deer, and in this video we are going to look at evaluating functions when the function is defined as a graph. So we saw that we can define a function symbolically, we can define a function verbally, we can define a function using a set of points or a table of values, and we can also define a function via a graph. Next class, we'll look at translating between the different ways of describing a function. So here, let's really kind of key in on how to just read this graph. That's what this lesson is really all about today, or in this video, is how to understand a graph as the inputs and outputs of a function. So we have the graph of g of x equals y. Note on this graph, g of x equals y, right? So the outputs of the function are y values. So let's just take a couple of points, for example, here. Like I've got this point on the graph. So this is the point 4, 3. And since that point is on the graph, that's saying that g of 4 equals 3. I look at this point right here. This one's not on a what's the word I'm looking for? It's not at the corner of the grid lines, right? So this is like approximately 4.2, give or take, comma 4. This is an approximation. So we could say that g of 4.2 is approximately 4. If I looked at a point like down here, this is not on the graph of g. So that's not a point that is part of the function. If I input 4, I would not get -2. I would get the output of 3, right? So if I input 4, we go up to the line from that input of 4, and we see that the y value on that graph is 3, so that's the output of the function. Let's note what a graph is. This can be overlooked sometimes. Like if we're saying, what is a graph of a function? A graph of a function is a visual picture or representation of how the inputs and outputs of the function are related. Let's note a couple things. The coordinate plane is not the graph. If the parabola here, if the blue line, g of x equals y, if that wasn't there, I wouldn't have a graph. I would just have a blank coordinate plane. It's like, I like using the analogy, if we're looking at a map, and we've got all of these grid lines, we've got like A, B, C, D, E, and F on the bottom, and we've got 1, 2, 3, 4, 5, 6, 7, and 8 here, and we can draw all of the grid lines for this. To divide up the map into regions, but if I stop here and I don't draw a map underneath these grid lines, I don't have a map. I just have a blank like place to put a map. So when I say what is the graph, it's the blue line. It's not the coordinate plane specifically. Okay, so just wanted to be clear on that. So as I look at the graph of g, the blue line, the parabola here, I can say that every point, and that's not just the whole numbers, but the decimal numbers, the fractional numbers, all of them, every point on the graph shows the output y value of the function for a given input. Usually x value to the function. All right, so that's how we're reading these graphs. Let's take a look at these examples and make sure that we're understanding this. So say we have g of 2. You want to say, okay, if the input is 2, then I find the point on the graph where x is 2, right? The x values are the inputs. So this is the point 2 comma negative 1. So the y value, the output when x is 2, is negative 1. Then we say, what's g of 3? So I go to where x is 3, and I see that this is the point 3 comma 0. So g of 3 equals 0. The output of the function g when x is 3 is 0. All right, then we get into some approximations here. G of negative 0.3. So I'm going to say, okay, negative 0.3 is about here on the x-axis. So if I go along my blue line, if I'm reading that left to right, I want to go up to the point on the line. This is the point on the parabola, on the function g, where x is about negative 0.3. We see that the output is probably 4. So I'm going to say approximately 4. I'm going to use that squiggle line to indicate that I have approximated and that I'm not sure that that's an exact value. Okay, and that's because really that negative 0.3, it's kind of hard to tell where exactly that is, but we just want to note, like if I'm looking real close at this graph here, here's the negative 0.5, so I'm trying to get a little bit closer to that halfway line than I am to 0 as I move towards negative 1. And then go straight up to the blue line to find the y value that corresponds to that x value on the line itself, on the line that is the graph of g. All right, g of 2.5, so I go to 2.5 as an x value, and I go on the blue line. This is the point 2.5 comma, we've got to approximate this. This is maybe negative 1.7. So I find the point where x is 2.5 on the line and say that that is approximately negative 1.7. All right, so we're going to keep diving into this. We're going to do another example. Pause if you need to make sure you've got that all figured out. Let's move on to this next one. Then I'll give you guys a chance with a now you try set of problems there. So I've got a new function f of x equals y. So the y values on this is really the graph f of x equals y down here. So we're saying that the vertical axis is outputting the y values, or the outputs of the function, while the horizontal axis is the inputs for the function. And in this case, we are solving equations rather than evaluating for a given input. So here we're given the outputs and we're looking for the inputs. So for the first part, part A, f of x equals 1. Actually, let's kind of just talk about this graph a little bit. Let's note that as we read it from left to right, and this is how we read graphs, is from left to right, the y values are going up and down between -1 and +1. They start at -1, they go up to 0, and then up to 1, and then they go back down to 0. They hit all the numbers in between +1 and 0, and then they go, so from -1 up to 0, and then they keep going up to 1, and they come down, they hit 1/2, 0.1, 0, -1/2, -1, all the numbers in between there, -0.2, -0.1, 0, 0.3, 0.6, 1, all the numbers in between 1 and 0, then it gets to 0, goes back down to -1 when x is 3. When x is 3.5, the y value looks like it's probably about -1 and it's hard to tell, but a half-ish, maybe 0.6, 0.4. And then it goes when x is 4, y is 0. When x is 4.5, it looks like we're up at like 0.7. Yeah, that seems better. And then when x is 5, we're back to 1. So we see the y values are going back and forth between -1 and +1, hitting all the y values in between that as the x values move from left to right from -5 to +5. So we want to say, okay, solve f of x equals 1. So this is when is y equal to 1. So if I go to 1 for y here, we see that this occurs at that point. This is the point 1, 1. And then it occurs again over here. This is the point 5, 1. And this is the point -3, 1. And it looks like this keeps repeating. Right? And it looks like it's happening every 4 units. We go from -3 to 1, and then to 5. So we've got y equals 1 when x equals -3, +1, +5, and then if we keep going by 4s, 9, 13, etc. And then also if we went backwards from -3, we could say -7, -11, -15, etc. Right? So we'll use these ellipses, the 3 dots here, to say that this is continuing on in this pattern. So for f of x equals 1, we'll write the solution set is the set containing, we can use these ellipses just like this, dot, 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 -7, comma, -3, comma, or +1 now, comma, 5, comma, 9, comma, 13, comma, dot, 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 and then close our brackets there. So there's an infinite number of solutions to this when y equals 1. All right. Now we want when is the y value for part B, f of x equals 0.5. I'll do this one in purple. So when is y equal to 1/2? So I'll go up here and say, okay, 1/2 for y. 0.5. I'm going to zoom in on this. And this is happening pretty often. Oops. It's happening there. It looks like it happens there again. And then here. And here. And here. So it looks like that's when x is about 0.3 maybe, and then 1.7, and 4.3, and back on the left side, negative 2.3, negative 3.7, etc. So we'll just list those out and say y equals 0.5 when x is approximately, I'm going to write dot, 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 negative 3.7, comma, negative 2.3, comma, 0.3, comma, 1.7, comma, 4.3, comma, dot, dot, dot. And so we could be more precise and find this pattern, but we don't want to go too crazy right now. We just want to make sure that you're understanding how to read this graph and how to find those solutions to these equations. If we're solving an equation, we say, okay, the y value is 0.5. What are the x values where the line takes on a y value of 0.5? And it's at those points that are drawn here where this graph takes on a y value of 0.5, and so we can approximate those x values as we've seen here. So we'll write the solution set is the set containing dot, 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 negative 3.7, negative 2.3, comma, 0.3, comma, 1.7, comma, 4.3, comma, dot, 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 close our set. So that's the ellipses are just indicating that there's a pattern here that we could keep following without us specifically finding the mathematical. So we could technically find the mathematical expression for what this pattern is, but we're not going to worry about that today. All right. Next thing that we're looking at here is solve the equation f of x equals 0. Let's do this one in blue. So I go to the graph. I'm going to zoom in here. We see that the graph is hitting a y value of 0 on the x-axis at these points I'm drawing now. This is the point negative 4, comma 0, and the point 2, comma 0, then 0, comma 0, and then 2, comma 0, and then 4, comma 0. There's a pretty obvious pattern here. So y equals 0 when x equals dot, 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 negative 4, comma, oops, that should be a negative 2 there. Try to fix that, okay. Messing up our flow. Negative 4, negative 2, comma, 0, comma, 2, comma, 4, comma, dot, dot, dot. So f of x equals 0. The y value is 0 on the x-axis. So we can say the solution set is the set of values dot, 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 negative 4, comma, negative 2, comma, 0, comma, 2, comma, 4, comma, dot, 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 close our set. All right, and then we got just one more before we give you guys the now you try problems. So we want to know, when is f of x equal to negative 2? When does f of x output negative 2? It's saying, when I use the word when, I mean for what x values, what inputs x values will we get a y value of negative 2. So let's look at this line and let's note that this just continues in the same pattern for forever. And if I go down here to where y is negative 2, the graph never gets to a y value of negative 2. Graph never takes on an output of -2. So the solution set is empty. There's nothing in it, no solutions to this equation. All right. Thank you so much for watching, everybody. Go ahead and give the Now You Try problems a shot on this, and then once you've done that, go ahead and watch the video to check your answers on those. And that's it. This is the last topic for this lesson. Finish those up, and then next class we will talk about all of these. Thank you much. See you in the next one.